Alright guys, like I said earlier, our next big topic is exponential functions. We can't get into exponential functions until we get into laws of exponents. And that will then drive us deeper into polynomial functions and quadratics. But again, we have to get through this next topic of exponent laws. Now this is an 8th grade topic, so it's not anything too difficult with Math 1. But we are going to amp it up a little bit. We're going to start off slow. I'm going to introduce these topics to you guys, and then from then on, I'm going to start incorporating more and more laws into each problem. But for the next 2 days, we're going to take it law by law. I'm going to explain what each law is and how it's done, and I'll show you multiple ways to do it, and then from there, we should be good to go. So, the first law we're going to take a look at, well, actually, before we even take a look at laws, let's first understand something huge, okay? If I'm looking at this is called 5 to the 8th, okay, or 5 to the 8th power. You guys have probably heard 5 squared, which is this. You guys have probably heard 5 cubed, which is something to the 3rd power. But there's no fancy word for anything higher than cubed. So we just say to the 4th power, we just say to the 5th power, we just say to the 6th power. In this case, we're saying to the 8th power. This does not mean 5 times 8. Exponents do not infer that's the number you multiply it by. In this case, 5 is called the base. 8 is called the exponent. I'll also call it the power from here and there, but again, I'll switch back and forth, power and exponent. But again, it does not mean 5 times 8. In essence, it really means 5 times 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 5. There are 8 factors of 5 you're multiplying by. That's what 5 to the 8th means. So this little exponent tells you how many factors of the base you're multiplying by. But you guys should already know that. So just to review, let's go into our first law, product of powers. Now again, when we're multiplying these, if I'm looking at this, I have 3 to the 4th times 3 squared. I'm not going to do the law right away. Instead, what I'm going to do is I'm going to expand what these really mean, just like we had up here. So 3 to the 4th is 3 times 3 times 3 times 3. 3 squared is just 3 times 3. If I look at these, I have 6 factors. So in essence, 3 to the 4th times 3 squared is really 3 to the 6th. Now, do I want to actually know what 3 to the 6th is? No, I don't care at all. Okay, there's no point in doing that right now. All we're doing is simplifying these expressions down. We're taking larger expressions and bringing them down into hopefully one expression or a handful of terms. But again, notice, when I multiply 3 to the 4th times 3 squared, there's actually 6 factors. So after this first example, I'm sure you can think of the law. The law is quite simple for product of powers whenever we're multiplying like bases. But let me go through the next one just in case. Let you guys try to think of it on your own before I give it away. Second one, x squared times y to the 8th times x to the 5th times y cubed. Now we don't have the same bases everywhere, okay, but we do have some. Now using the law, or not using the law, but using the commutative property, I'm going to switch these around real quick. So now you guys can see I have 2 factors of x here, 5 factors of x here, 8 factors of y here. Oh, God. That's a lot. 5, 6, 7, 8. And I'm going to circle it back down. 3 more factors of y. So in essence, I have 1, 2, 3, 4, 5, 6, 7 factors of x. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factors of y. Now, let me ask you, can I multiply these together? Can I take x to the 7th and y to the 11th and multiply them? The answer is no. Guys, think of it like combining like terms. Okay? Whenever you're multiplying these bases together, you have to have the same bases. If you don't have the same bases, you can't do anything with them. Okay? So again, when you have a base with an exponent, and they're different, you can't combine them like we have been doing. You can just leave them like this. So the final answer is x to the 7th, y to the 11th. So instead of having 4 big terms, now we only have 2. Now, after these last 2 examples, you've probably seen what the law is. I'm not having you guys expand everything all the time. That's ridiculous. That's way too much work. I want you guys to actually think of the law yourself, because again, the product of powers, multiplying like bases, it's not that complicated to figure out. Hopefully you've noticed by now, when we're multiplying like bases, we take our exponents and add them. I have 4 plus 2, that's 6. I have 2 plus 5, which was 7, and I have 8 plus 3, which is 11. So again, that's the law. It's pretty quick, it's pretty painless, guys. It's not that difficult to comprehend. You saw after I expanded it out, that's what's going on. But again, I want you guys to understand the conceptual reason, not just a law. Anyone can remember a law. I want you guys to actually be able to understand and see it happening. Now, if I look at the last one, some things are slightly different. We have variables and we have coefficients. You tackle this problem the same way with like bases. This 5 and this 3 are not bases right now. This 5 does not have an exponent, this 3 does not have an exponent. The exponents are only with the x and the 4. So since they're only with the x and the 4, those are the bases you're going to worry about. You handle the coefficients just like the operation says. So since we're multiplying, I'm going to take my 5 and I'm going to take my 3, I'm going to multiply it and get 15. Now, I have 2 factors of x here. I have 4 factors of x here. That means I'm going to have 6 factors of x altogether. Again, guys, the most difficult part about these laws, in one by one, they're not hard. Doing the product of powers, doing the quotient of powers, doing the powers of powers, they're not difficult by themselves, but you can mix them up very easily if you're not comfortable with them. So again, while you're working with these guys, really make sure that you're understanding which one's which. Really understand that, all right, when I'm multiplying bases, I have to add my exponents. I'm not adding coefficients. These are just numbers being multiplied together with the 5 and the 3. I am adding the 2 and the 4, though. So again, making sure you understand that difference is going to be huge, huge, huge to being successful in this this topic. Okay? Now, at this point, I have 3 problems for you guys to work on. Don't worry about the negative exponents. Just keep going with them as you would. We'll get to negative exponents tomorrow, but just work with them as you would. You can pause the video now. You can try them on your own if you want. I'd actually appreciate that if you tried that. Or you can follow along because I'm about to go through them right now. So again, pause the video. I'm going to start working. Now, if I see 8 cubed and 8 to the 6th, I can use the law. I know 3 plus 6 is 9. That means I have 8 to the 9th. I don't care what 8 to the 9th is. It's some ungodly large number. But in case you're wondering why, again, I have 3 factors of 8. Then I have 6 factors of 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 total factors. That's why I have 8 to the 9th. Again, I don't care what 8 to the 9th is. I really don't care. Number 2, I have 3 terms I have to multiply together. If I take a look, I have 2 coefficients, and then I have 3 variables. All the variables are the same. All my bases are the same. One thing that could help you out with this is, since this is all multiplication, you can rearrange things how you like to put things next to each other. For example, if I wanted to, I could put the 5 and the 3 next to each other. Then I can put the x to the 4th, x to the 9th, and x. This way, I know I'm multiplying 5 times 3. So again, if you guys want to use the commutative property in the beginning, since you're just getting your feet wet with these topics, move them around and put them next to each other so you know, all right, I'm multiplying these, I'm not adding these coefficients. I cannot make that mistake because that is going to be an easy mistake to make. Please be careful with that. 5 times 3 is 15. Now, if I'm working through this, x to the 4th and x to the 9th, that's 13. But there's no exponent here. If I'm looking, there's nothing. So Mr. Z, what do? What exponent goes there if there's nothing written? Just like when you have a variable with no coefficient, there's supposed to be a what in front of it? There's supposed to be a 1. So when you have no exponent written, there's really a 1. That's also a big mistake students make with these. When you guys are working through these and you have variables with no exponents written, please, please, please write a 1 in place, especially in the beginning of this topic. That's going to help you from making the mistake. Because you may be prone to saying, oh, 9 plus 4 is 13. Boom, done. But you have to remember there's a 1 right there. That means it's 15x, not to the 13th, to the 14th. Because 4 plus 9 plus 1. All right? And last one, guys, I'm going to order my numbers, my coefficients together, my c's together, and then my d is going to be at the end. So I'm going to have negative 4 times 7 times 2 times c cubed times c to the negative 2 power times d squared. Again, all I'm using is my commutative property. There's nothing crazy going on. Multiply. I'm going to do 4 times 2, which is negative 8. Negative 8 times 7, which is negative 56. So it's negative 56. Now, remember, you're adding exponents. You're not multiplying them, you're adding them. 3 plus negative 2 is 1. You can just write c. If you want to write c to the first, you can. You don't have to. You can. There's nothing else to multiply this base of d with. I have 2 bases that are the same. I have 1 that is not the same. Don't do anything with it. Just rewrite it. So my final answer is negative 56 c d squared. Again, guys, that's product of powers. Nothing crazy, nothing fancy. Obviously, it's going to get much harder because this is only one law. When I give you 2 laws and then 3 laws and then the 4th with negative exponents, when we start doing all these problems together in one, we're going to mash them all up. Problems can get difficult. And by difficult, I mean easy as long as you remember each law and as long as you take your time. Again, just like longer equations aren't more difficult. They're just more tedious. Same concept with this. These are not more difficult, they're just tedious and very error prone. So again, be careful and we should be solid, right? Right. Okay. Second law, powers of powers. Raising a power to a power. So sometimes you're going to see something that looks like this. This is 6 squared raised to the 3rd power. What this is really saying is I have 3 factors of this. So I have 1 6 squared, I have another 6 squared, and I have another 6 squared. Again, the exponent lets me know how many factors I have. I have 3 factors of 6 squared. Now, if I really dive in deeper with this, I know 6 squared is just 6 times 6. I know this 6 squared is just 6 times 6. And I know this 6 squared is just 6 times 6. So again, remember guys, the exponent tells you how many factors. I have 3 of these things. And when I break it down even further, I have 2, 2, and 2. If I count how many factors I have, 1, 2, 3, 4, 5, I have 6. I mean, I get there's a lot of 6s. It has nothing to do with demonic rituals, I promise. 6 to the 6th. 6 to the 6th. Again, take a look at the question. Take a look at my work. Kind of try to figure out what the rule is before we go to the next problem. I'm sure you can see how I got 6 to the 6th very easily by looking at our exponents. But, again, understand the concept. Understand how I broke it down. understand why I wrote these 3 numbers down, and then understand why I wrote these 6 numbers down. Again, guys, I'm not just here to give you a rule and move on with it. I'm trying to educate you and help you learn this conceptually. All right, second one, x to the 5th squared. This exponent is telling me I have 5 of these bad boys. So, sorry, I lied. This exponent is telling me I have 2 of these things. So I have one factor of x to the 5th, and I have another factor of x to the 5th. That means I have 5x's here and 5x's here. If we use our product of powers, if we use the rule we came up with, we know I just add my exponents here. So 5 plus 5 is 10. X to the 10th. So you can see how these rules intertwine. I can use product of powers to do power of powers. Now, if you take a look at these last 2 examples, 6 to the 6th, x to the 10th, again, I don't care what 6 to the 6th is, I'm just leaving it as 6 to the 6th. What is the rule? How can I get 6? How did I get 10? It's pretty straightforward, guys. I'm multiplying these exponents. Whenever you have a power raised to a power like this, especially with parentheses involved, when you have a power on the outside of the parentheses, you multiply that to every exponent inside. I stress, every exponent inside. Okay? So this 3 times 2. This 2 times 5. It's kind of like distribution for exponents, so to speak. If I go to the next one, I have 2 terms. Now notice how this question not only has powers of powers, it also has product of powers. I have a base of n here, I have a base of n here. So again, this question combines the product of powers to the power of powers. Just like in math, guys, every other question we've done, how we tackle these larger questions, take your time, be careful, and just go step by step. You know, with distribution, if you want to think about it that way, you can't touch anything until those parentheses are gone. Same concept applies here for the most part. Get rid of your power to a powers. Get rid of those parentheses. Let's see what happens. So again, if I follow my power of power rules, 1/2 times 10 is n to the 5th. Now, Mr. Z, there's a power on the outside. I have multiple terms on the inside. What in the world do I do? Like I said earlier, it has to go to everything. Mr. Z, there's only one exponent there. Remember, when we don't have an exponent written, that means it's a 1. So this is really 2 to the 1st. That 2 is times 1, so I really have 2 squared. I'm going to have n squared here. 2 times 2. N to the 4th. Again, when I have a power on the outside, I multiply it to every single exponent on the inside. Even though it's written 2mn squared, don't forget, and I'll use a different colors to show you, there's a 1 right here, and there's a 1 right here. Yes, coefficients still have exponents, okay? Especially when you have them inside parentheses, those coefficients have an exponent. One of the biggest mistakes I see every year is students do not multiply the exponent on the outside to the exponent of the coefficient on the inside of the set of parentheses. Please, guys, be careful with that. Do not make that same mistake. If I'm going through this, it's pretty straightforward. I'm going to rearrange it to make life easier and to just show you guys, keep rearranging, keep putting it next to each other. I have an add 2 squared, which I'm going to make 4. I have an m squared, then I have an n to the 5th, and the n to the 4th. And typically, our nomenclature that we use, the way we write these things, guys, I always write my coefficients first. You can write n to the 4th times n to the 5th times 2 squared times m squared if you really want to. But again, typical mathematics are written coefficient first, then variables, and typically variables are written in alphabetical order. I'm not saying you have to. I'd like you to, but again, just try to follow that rule as best as you can. 2 squared is 4. I will do that one because that's easy. M squared, I only have one m. I have no other base with m. N to the fifth and n to the fourth. I've used power of powers up here. Now I need to use product of powers. So remember, when I have like bases, I'm not multiplying these, I'm adding them. N to the ninth. So my final answer, 4m squared, n to the ninth. Hopefully, I've been clear. I've been pretty straightforward with you guys about what we're doing here with these laws. I've shown you conceptually what happens. So hopefully you can get a grasp on this. Again, I'm going to start these next 3 exercises. If you guys want to go through and do them first and then check your answer, I'd appreciate that, because again, you guys can only learn this by A, doing it yourself, and B, learning from your mistakes. So if you try it and get it wrong, that's cool, all right? Making mistakes is normal. Fix those mistakes is what education really is. So again, pause the video. I'm going to start. P to the fourth to the fifth. Again, this is saying I have 5 factors of p to the fourth. 1 factor, 2 factors, 3 factors, 4 factors, 5 factors. And what this really means, 4, 8, 12, 16, 20. And again, I could have just done 4 times 5, Mr. Z, why are you being so extra? Again, I'm trying to let you guys see conceptually what it really means. I don't want you just so dependent on the rules. That's the last thing I need. I don't want you guys mindlessly and blindlessly isn't a word, blindly following a rule without knowing what's going on. Next one, 3g to the fourth cubed. Now, remember, this exponent goes here and here. Because, remember, this is 3 to the first times g to the fourth raised to the third power. So this 3 is going to go here and here. So it's actually 3 cubed and g to the 12th. Because again, 4 times 3 is 12. Do not get powers of powers confused with product of powers. Okay? 3 cubed is 3 times 3 times 3, which is not 9. By the way, it's not 9. It's 27. G to the 12th. Straightforward, right? Nothing crazy, not difficult. You guys should be able to handle this. Last one. I am going to use the rule straight out. We're just going to go with it. I assume you guys know what's going on. When I distribute this exponent to the other exponents, it's 6 cubed, a cubed, b cubed. When I distribute it here, it's 5 squared, negative 6. I'm going to rearrange these numbers and these terms so I have like terms next to each other in order. So, 5 squared times 6 cubed times a cubed times a to the negative 6th times b cubed. Now, here's where things, you may hear me say one thing and then you may hear me say do another. 5 squared is easy. 5 squared is 25. 6 cubed is semi-easy because we know 6 cubed is 216. 6 times 6 times 6. But then we have 216 times 25. That's gross. Okay? You can do it. I don't care. And given that all your answers are multiple choice, you're going to understand how they want you to write your coefficients. In this case, I'm going to leave it because I'm lazy. End of story, because I'm lazy. If you really want to know what 216 times 25 is, 216 times 25, 5,400. There. Because I know someone's rolling their eyes, probably Josue or Lily. 5,400. A cubed times a to the negative 6th. Remember, when we multiply like bases, that's product of powers. We have to add. So it's going to be a to the negative 3rd. And I have no other like base for the b, so I just write b cubed. And that's it, guys. That's product of powers. That's power of powers. That's everything you guys need to know. Yes, it will get much more difficult than this, and by difficult, I mean a lot more tedious, but you guys can handle it. Again, we're taking things slow, and we're not going to get out of control until tomorrow. And even then, it's not going to be completely crazy. Just take your time. You guys should be good. I'm going to stop this video. The next video will be the exercises on the back. I will go through them for you. You guys can follow along with me if you wish, but I'd rather you guys do the problems in the back by yourself and then check your answers. There's also an exit ticket at the back of the page. This is how I know how much you guys learned today. It's 2 simple questions. If you understood the concepts, it shouldn't be a problem. It will be in GradeCam, so make sure when you do these 2 things, when you do those 2 exit tickets at the end, or those 2 questions at the end, you log into GradeCam to put your answers. Otherwise, that's it for this part, guys. Hit the next video. Make sure you hit that subscribe button because I'm the coolest, and that's a plug. I'll see you guys later.